Chris Clark here with Wastel. Today's Tech Talk is on common laminating defects.
Let's start with a quick review. From our previous discussion, we know there are 5 common defects that can be created during the lamination process. They are inadequate bond strength, poor clarity, such as bubbles or haziness, curl, wrinkles, and tunneling. Now we will discuss causes for each of these. The laminate's ultimate bond strength is determined by the adhesive's specific adhesion to each web surface and the inherent strength of each adhesive and substrate. This is further complicated by effects of contaminants on or in the adhesive or material applies. Many techniques are used for bond enhancement: selection of adhesive type and amount, surface preparation and primers, corona treatment, temperature control, pressure, and dwell time. Of these, only temperature, pressure, and time are laminator related. Techniques to improve bond strength include gradually increasing laminating roll temperature, gradually increasing nip pressure, and slowing the line to allow for increased dwell time. A transparent laminate, unless designed for translucency, should have clarity and freedom from visible imperfections, at least to the degree of the individual components. However, this standard is difficult to achieve in practice. The most common degradation in laminate clarity is caused by incomplete contact across the adhesive and secondary web interface. Causes of clarity problems include insufficient adhesion to the secondary web, residual adhesive patterns resulting in high and low points which are not flattened in the nip, contaminants in the adhesive or on the web, and machine-related problems such as roll bounce, dirty roll surfaces, inadequate nip pressure, or insufficient roll temperature. There are several areas to consider when addressing clarity problems. These include increasing the adhesive volume being applied, reducing humidity in the coating area, and considering air entrapment between the webs, which can be caused by improper lead-in angle to the nip, low nip roll durometer, low nip roll pressure, or insufficient nip temperature. There are 3 types of curl defects found in laminating: machine direction curl, which can be caused by an incorrect ratio of primary to secondary web tension, or by the differential heating of the laminate components inherent in a combining nip together with different coefficients of expansion. Most of these effects can be eliminated by adjusting the tension ratio. Also, maintaining minimum tension into the laminator is always a good practice. The second and third types, cross direction or transverse, and diagonal curl, are more difficult to control. Efforts to improve optical quality usually lead to ever-increasing combining temperatures. Transverse curl then becomes a frequent problem. As pressures are increased, the non-uniform width footprint leads to the development of diagonal curl. Web preheat and the ability to skew the elastomer-covered nip roll are the tools frequently used to eliminate this type of curl. Wrinkling in the combining nip can be the result of one of 3 things: insufficient pre-contact wrap on the elastomer roll, incorrect secondary web tension, or non-uniform side-to-side pressure. The actual case is easily determined by inspection. A wrinkle which maintains an essentially constant position is probably related to high tension. those that move erratically, accompanied by web steering, indicate insufficient tension. Our last laminating defect, tunneling, is a defect that is synonymous with poor adhesion. It is a manifestation of insufficient bond strength to overcome the elastic forces of incorrect web tensioning. Examination of the web will show which one is under the highest tension, since the tunnels will be in the low tension substrate. From there, adjustments can be made to equalize the tension of both webs. Additional causes of tunneling include poor wetting of adhesive, which causes the film to separate in those areas with low adhesive concentration, and insufficient cooling of the webs after lamination. If you have a laminating project or other process that needs assistance, please consider the Fostel Technology Center as your resource for all things web converting.
Thank you for joining me. Please contact us so we can help with your equipment needs, and see you again soon with another Fostel Tech Talk.